Hello. I'm going to start talking about math and numbers because those are things I want to talk about. And a lot of people, they say that they're not good at math when really they are. They're just not good at the way that schools teach. I have a very big problem with the way schools teach math. So I think I'm going to start teaching math the way that I understand it and the way that I can try to help you understand it, because math is the language of the universe. It's everywhere. Numbers are everywhere. From the time that you wake up, you see the time on your phone. Numbers are everywhere. And people don't know how to use them properly. Or people don't know how to manipulate them properly because of the way schools teach. And schools teach you to memorize. Schools teach you how to manipulate numbers, but they don't teach you what they are, or what they can do, or what they mean. Everything in school is just 2 plus 2 equals 4, and here's the quadratic equation. If you ever need to find, the slope of a line, you know what I mean? It's all just like, it's like arithmetic. It's just, here's how you manipulate this stuff. And it's just like, why the hell do we even need to know it? I got to teach a math class because the kids in that class were like, when am I ever going to use this? Why do I have to learn math if I'm never going to use it? And so higher forms of mathematics most people aren't going to use, and you don't have to learn them. But the majority of us still struggle with basic arithmetic, and it's because we never fully grasped it in elementary school, and they moved on faster than the way that we grasped. So I have a problem with school and the way that schools teach because they move too fast for me to understand. This crap. Anyway, schools teach too fast for me to understand. For me to understand something, I have to break it apart piece by piece and understand the individual pieces before I can move on. And schools are just like, oh, here's how springs work, and here's all the math that you need for the physics of springs, and then here's kinematics, and here's how motion works, and we're gonna move into bell curves. You know what I mean? It's like they just like move week by week into new subjects. They don't give you time to fully grasp what the hell's going on before they move on. So you got the Swiss cheese paradox, I guess I'm gonna call it. If there's a kid in elementary school, here's his understanding of mathematics, right? This is like 100%. It's like, I don't know, it's a sheet of paper, it's cheese, okay? This is cheese. And if you understood everything that the schools taught, this would be complete. But, maybe that kid in elementary school, maybe he got an 80% on his final test, okay? He didn't fully understand how to add 11 plus 7. I don't know. And then maybe he also didn't fully grasp how to multiply by nines, right? These are two areas that he didn't master, but now he's going into middle school. And so in middle school, he's now starting with an 80% understanding of math. And then from there, on his final exam, moving into algebra, and you've got decimals and fractions, and you're starting to understand like slopes and stuff. Well, maybe then he only gets an 80% in middle school. And so now he's down to like a 60% of full understanding, right? So maybe he didn't grasp the way that fractions work, and maybe he didn't fully grasp the way that decimals worked. I don't know, percents. So now he's only got 60% of understanding. And then he goes into high school. And now in high school, he's trying to grasp Algebra 2, and he's trying to grasp geometry, and he's trying to grasp trigonometry, and pre-calc and stuff like that with only a 60% understanding. And so trying to move forward too fast doesn't give you, you can't move forward. They just keep on throwing more and more difficult information at you when you don't have a full grasp of what you're doing. And that's the problem. So with the way that I'm teaching math and the way that I'm learning it and understanding it, we're adults now. I don't know if you know that, but I'm an adult now. And there's no tests anymore. I can take as long as I want to master something before I move on to the next subject. So if anybody ever does follow my stuff, work with it at your pace. If I make videos or whatever, if I start explaining stuff you don't understand, don't watch those yet. Stay where you're at. I'm relearning the way that I understand arithmetic. And I thought it was going to be quick because I thought that I was studying arithmetic the same way that school taught me to do it, memorization. And I realized that I don't learn by memorization. That's not the way it clicks in my head for me to actually learn how to calculate. So my form of calculation, I don't do my math every day. I get to it a few times a week. But I've been working on addition and subtraction for a few months. I don't fucking care. I'm not embarrassed because I'm learning it the way I'm learning it at my own pace, at my own time. So there are no more tests. There are no time limits. Work with it at your own pace. So with that being said, numbers. What are they? Okay. Numbers are a representation of something. So numbers represent things. You typically have three kinds of maths. Okay? You got like the physical world. That sounds really funny, doesn't it? Physical, theoretical, and manipulation. Okay. So the physical world, this is geometry, right? This is geometry, trigonometry, physics, quantum physics, engineering. That's all physical world stuff, okay? How many markers do I have? This is in the physical world. I have 3 markers. So the number 3 here represents the number of markers that I have. So understanding the physical world is one way that we use math and numbers. This can also be the odometer on your car. You know, it's something measurable. Wavelengths are measurable. Time, the sun's movement, we use numbers to measure that and break it up. So this is the physical world. Theoretical moves into, once you understand the way that numbers, the way that physical numbers represent in the physical world, you can start using those ideas as concepts. So this is also concepts. These are also concepts because it's like theoretically how do things work that we can't use yet. Higher forms. You know, most people know Big Bang Theory. Sheldon, he's a theoretical physicist because you use physics to base your theories on. String theory is a theory because it's theoretical physics. And then you have manipulation. And manipulation is how to work with numbers. So this is going to be like arithmetic, how to add and subtract, how to multiply and divide. Algebra is manipulation, and calculus is manipulation. So in order to work with things in the physical world, you have to know how to manipulate them on paper. And it's all based on it's all based on this universe. You know what I mean? So you've got 3 main types of maths, right? I'm going to turn this down. So anyway, you notice that most people that aren't good at theoretical math are good at physical math. So if you weren't good at algebra, you probably liked geometry, okay? Because theoretical and concepts, these are the main 2 that you're working with. So it's like when you're doing equations in algebra, you know, 2x plus 5 squared equals y. You know, this is a concept. This doesn't represent anything in the real world. It could, but this is just an idea. It's just a theory. And then understanding how to like find your x and your y, you're using a type of manipulation. And so most all of school deals with theoretical mathematics and how to manipulate the theoretics, because those theoretics can be used in the physical world, but high school students have a hard time understanding why they need to understand math. Why do you need to know how to find y or x? Why do you need to know that? You're not going to use it in real life. So most high school students like geometry because geometry is real. It's physical. You can measure things out. You can find the volume of a cube using geometry. And so geometry clicks with people better because they can actually physically see why they're doing the math instead of just dealing with the theoretical concepts of mathematics. And so some of us like theoretical mathematics. It's fun. A lot of people don't like theoretical mathematics. So guess what? Don't learn it. Don't worry about it. It can help you. Yeah, algebra. Algebra is very useful to know. That's how you calculate the gas mileage of your car, your miles per gallon. You do that using algebra. So there's times that you use it, but most people aren't going to need to know how to calculate a parabola, quadratics. Most people don't need to know that. The only type of math that you're going to use in your daily life is arithmetic. Okay. Oh, I've been working at this company for 23 years, but my first 5 years I was in the plant, and now I'm a manager. So if I worked at the company for 23 years, how many years was I a manager? 18. How many years was I in production or whatever? 5. So, this is a real world example. I was talking to a UPS worker. This is a real world example. She said, "What's 23 minus 5?" It was actually the other way around. She said 23 minus 8. But anyway, she couldn't calculate for the sake of to be true. 8 equals 15. This UPS worker that I was talking to has worked with UPS for 23 years. She was in the warehouse for the first 8 years. She's been a driver for 15. So I'm in the real world, and she says, I've worked at the company for 23 years. What's 23 minus 8? She asked me that because she couldn't do the math in her head to come down that she's been a driver for 15 years. So school got you confused with theoretical concepts. You don't need to know theoretical concepts unless you're going into a math field, unless you're an engineer, unless you're a physicist, whatever. You don't need to know the theoretical. You do, in the real world, you should know how to manipulate numbers. Yeah. And so, numbers, rational and irrational, odds and evens. I think I'll go into that on the next one. This is just kind of a overview, I guess, of my stance on math, because I'm doing this. I'm probably going to record the next few today because I'm reading in my history of mathematics book and I'm getting into it. But numbers, what are they? Okay, to recap, they represent the physical world. They're representations of things. I guess one more thing that I'm going to add on to this before I end it. Most non-math people don't realize that what you're taught in school is called classical arithmetic. 2 plus 2 equals 4 is classical arithmetic. Okay? There is classical modular arithmetic, which I'm going to get into with mod 10 and 5. But modular arithmetic is like clock math. On a clock, 12 plus 2 is 2, not 14. Because once you hit that 12 mark, you start back at 1. So there's modular arithmetic. There's surreal numbers. Fuzzy arithmetic is like statistic and probabilities, because the numbers don't actually represent real things. They represent like concepts. They're not, the numbers aren't exact. So you got fuzzy arithmetic, constructivist arithmetic, p-aditic arithmetic. You have tropical arithmetic, which they use for traffic flow. Interval arithmetic, Boolean arithmetic, Poirot arithmetic, hyperreal arithmetic, ordinal arithmetic. There's all different types of maths. They just taught you classical because that's the easiest to work with. It's kind of like the foundation, because in in tropical arithmetic, it swaps your pluses for your minimums, and it swaps your times for your pluses for that traffic flow. So it swaps the way that arithmetic works. So that's just arithmetic. That's just me doing a short Google on the different geometry. You've got Euclidean geometry, where we all know like parallel lines and perpendicular lines, right? In Euclidean geometry. In non-Euclidean geometry, your parallel lines will eventually intersect. How does that work? How does that work? They're parallel. They don't. Well, it's because things curve. So you've got Euclidean geometry and non-Euclidean geometry. You've got intuitist math, projective geometry, where points of infinity exist, topological geometry, where shapes bend like a donut, fractal geometry, my favorite, differential geometry, curves in space-time. So there's all kinds of different geometries. Like classical mathematics or arithmetic isn't the only one. There's a bunch. So I'm creating my own type of arithmetic and number theory called spiral dynamics, because of the way that I understand numbers. Because the way that you understand numbers is going to be different the way that I understand them. Not all of us are good at classical arithmetic. We're not. That's okay. You don't have to be. How do numbers make sense to you? That's the point of this whole deal. So I can try to help you find the way that numbers make sense to you, because I'm finding the way that they make sense to me, and it's not classical. It's different. But I'm just finding the way that they make sense to me. So anyway, to wrap up, numbers represent things. Theoretical, physical, and arithmetic are the different ways that we work with numbers. Yeah, and go at your own pace. There's no more tests. School's out. You can be good at math. You can learn how to do minor calculations in your head when it comes to time or money. You know, you want to calculate a tip for somebody. You can do that. You can do that. You can learn how to do that. It's okay. It's okay to go slow. It's okay to make mistakes. You don't have to prove anything to anybody except for to yourself, because math isn't scary. It's very simple. School makes it scary. They scare everybody away from it. But you can do it. Yes, you can. And I want to try and help you do that. So, yeah, that's a good stopping point, which is what I'm going to get to in my next video. Stopping points. All right, cool. Bye.